controlling some motors. Okay, the motors can be different types, different ratings. They can be half ampere motors, 1 ampere motors, 5 ampere motors, or even more than that. And motors are also different types: DC motors, stepper motors, servo motors, and maybe in locomotives we are using AC motors. So maybe at least 1 hour I will give a talk on about these interfaces and how to control them. Then later on we will be using how to develop a GUI on computer, so that if you have some user interface, with the help of the user interface, how to communicate to some controllers what you are using last 2-3 days, then how the controller control the electromechanical things. As you can see, now this chain mounted motor is rotating here. Okay, this is the motor, DC motor, 12 volts DC motor, which is can take up to around 4 to 5 amperes of current. 4 to 5 amperes, imagine 4 to 5 amperes of current, 12 volts DC, warm gear DC motor. But if when you are free, you can come here closely see a big gearbox is there inside this. You can see this is called reduction of the gears. So finally, see what is the speed of this chain and what is the speed of this gear, right? This is, that's the meaning of reduction of the gears. Finally, this is the one which we will see in the lunch break. This is the one which is connected to that rooftop. There is a huge dish is there, 2 tons. 2 tons is the weight. The dish will rotate whole day, east-west, 180 degrees. The dish is mounted with so many solar panels, right? Actually not PV panels, these are mirrors. All these mirrors are mounted in a parabolic shape, and then the dish will focus the sun rays in a 300 mm radius. So at that spot in the 300 mm radius, if you measure the temperature, it will be around 1200 degrees centigrade when all the rays are focused. There are several applications right now. Popularly you can see in these community places like Mount Abu, Shirdi, Tirupati, all these places you will see 30,000 people's food is cooked by these solar rays, right? That means the solar rays are heating a small boiler, right? That will convert the water into steam, and the steam is used for cooking purpose. At a time around 30,000 people food is cooked in Shirdi and Brahmakumaris, Mount Abu and Tirupati. These are heavy installations. So wherever you have a huge requirement of steam, then those dishes are used. But as we know, even in PV panels also, we use it for tracking the PV panels from east-west. There are 2 types of trackings happens on the rooftops: daily tracking and seasonal tracking. When it comes to daily tracking, it is east-west. Early morning around some 6 to 7 will be east side, then slowly it will be moving to the west side. East-west is every 4 minutes, 1 degree is the displacement. So you will have to, whatever is your mechanical, electromechanical thing, whatever you develop in such a way that the dish, the 2 tons dish has to make a step every 4 minutes, 1 degree. So now you do all those calculations. 1 degree means what should be the speed of the motor, what is the size of the dish, what is the gearbox you are using, so that 4 minutes, it doesn't mean that after 4 minutes you make a 1 degree. In 1 minute, 1/4 of a degree or whatever. So finally it is the resolution. How accurately you want to track the sun is up to what kind of electromechanical things you have established there. It amounts to a huge power, remember. Even a small error, if your dish is not properly placed, if it is missing, tracking the sun by a few degrees, that turns out to be huge kilowatts of power loss. So that's why it is very, very important always to focus those solar rays on a smaller diameter, around 250 to 300 radius diameter will have to focus. Then only that heat energy is converted into steam. So this is one requirement. Nowadays, every country is talking about renewable energy, these things. So tracking a sun is the major issue there, because there are huge installations. We have installed on rooftop, it was our consultancy, we have supplied several of these kind of timers to industry. But otherwise, if you go to Mount Abu, their dish is 4 tons dish. The weight is 4 tons, double than this. Okay, this is 16 square meter is the aperture, but there they have 60 square meter is the size of the aperture. They have the huge machine, right? So imagine you require a crane to lift the dish. You require a crane to lift the dish, but however, that entire dish is rotated by the small DC motor. The question is clear. 4 tons is the weight of the dish. You require literally a huge crane to lift it. I will show you some photograph of Brahmakumaris, how they are mounting the dishes. Okay, 4 tons. But this is the motor which rotates the dish. Okay, so that is why I said, when you say robotics, it's not only just controlling the motor. It is also deal with this gear arrangement. How you convert this motion into its corresponding displacement there by properly mounting the gears. You will have to reduce the torque on the motor finally. Okay. Second is, imagine the motor is not inside the room, it's not in the laboratory, it is on the rooftop. When you say windmills, when you say these antennas or dishes, they are actually facing the weather. What is the wind speed? Just if you stand on the rooftop, you will feel the dynamic load of the wind, right? So that means, for example, in monsoon, if your dish is rotating and then it has to face the complete wind speed, against the wind speed it has to move. So if you try to make a displacement, there will be always a possibility that the motor will slip, right? You must have seen, no? Even when you on the road, sometimes you keep on pressing your accelerator, but then your vehicle tires are slipping because the load is so high that the engine power is not good enough to take away, right? Similarly happens here. Probably you have a 1 ampere motor or a 2 ampere motor, but then such a huge wind load is there. Obviously, there will be a backlash. It will be slipping back. Then how will you do the calculations? That is the problem. Okay, you think that every 4 minutes you will have to make a displacement of 1 degree. You do a lot of calculations and then you will write some few programs and you feed them. But then every day, based on the wind conditions, right, some corrosion on the motors, so displacement won't be constant, isn't it? Won't be constant. You think that if you switch on a motor for let us say 500 milliseconds, you think that okay, now displacement will be 1 degree. But that is not the case every day, every year, right? It will be differing. Then what will happen? Today you think that I have properly tuned, now all the calculations are correct. Tomorrow you will find that your dish is either going forward or going backward with respect to the sun tracking. Okay, so even that is not good enough to deal with. So that means you have to have a closed loop system. There is another issue, that is the biggest challenge. That means when you make a displacement by 1 degree, how will you confirm that the dish is actually moved by 1 degree? And if it is not displaced by 1 degree, then you will have to get a feedback that no, it is not displaced. Right? There is a percentage of error. So how to correct that percentage of error? So how will you calculate that PWM form, and then again you switch on the motor? So it has to be a closed loop system. How will you make a closed loop system? So what kind of feedback you will take it from a motors? Right? What kind of this thing? How will you measure the displacement? Any sensor is there? Okay, so there is people use various types of sensors, so that's why I thought at least 15-20 minutes we will talk about what kind of sensors we will have to use, what kind of motors we will have to use for this. So the sensors are different types, Hall effect sensors are there, but like in mouse, how will we measure the displacement? In mouse, how we are measuring that displacement and into its corresponding displacement on the screen cursor. There is a optocoupler. You can see there is a light. There is optical sensing is there. Same thing is there in this motor also. There are 3 wires are coming which are connected to the feedback control system. Okay, so it's not only a question of displacement, it's also you will have to measure how much displacement is actually happened, and if there is any error, that error has to again make the corrective action till the error is 0. And that is keep on happening, so that every 4 minutes 1 degree displacement as far as solar tracking is concerned. Otherwise, you will find n number of robotic applications. You can see such as small robotic arms, right, which are right now this is made up of plastic, but otherwise in industrial robots they are made up of metal. 5 motors, I will show you 5 motors are there in such a small arm. That means 5 degrees of freedom you will get. Similarly, that rover, there are around 3 motors are there for the rover. So like that, right? So the controlling the motors, and the motors can be such a small either stepper motors or servo motors, right, or DC motors, right? So basically in electronics we deal with either DC motors, right, or stepper motor or servo motor, whereas electrical people deal with the AC motors. That is the only difference. The difference is, just to tell you, in case of a floppy disk and hard disk, for several years people have used DC motors, that is stepper motors. Imagine in a floppy disk, in a 1.2 or 1.44 MB floppy disk, when you have hundreds and thousands of tracks on the floppy, imagine what will be the step angle so that the motor is moving from one track to other track. It is in less than an inch, right? In 1 inch you have around 3000 tracks are there. So 1 inch divided by around 3000, imagine what is the displacement factor on the one track to the other track, right? So that is the step angle in the motors. Today when you have a hard disk size is not increased. Hard disk is still 3 1/4 inch disk, right? Only thing is it made up of metal, aluminum plate. But now instead of storing, earlier we used to store some megabytes. Now today when you are storing terabytes of data, that means how many tracks must be there on the dish, and what is the distance between the tracks. Every day the distance between the tracks is coming down because you are increasing the capacity. Number of platters or dishes are not increased in the hard disk, they remain same. Size of the dish is never increased. But then imagine what kind of controller what kind of motor, what kind of control algorithm they must be using, so that the accuracy of the motor is moving the head from track to track in some micro inches is the displacement factor. That means this the dust particles which are not visible also can crash your hard disk, isn't it? Because it is in micro inches, the displacement factor in your hard disk. That's why you have seen those videos where it is a completely, the environment is dust-free environment, particularly this hard disk manufacturing and VLSI devices manufacturing companies. Okay, so I want to highlight that applications are many applications. It depends on whether you are using for some floppy disk or a hard disk, or the worst case applications are the motors which are directly placed on the rooftop and tons of weight dishes that are rotating. So robotics doesn't mean that it should have 2 legs and 2 arms and then eyes and head. Not that. Robotics means basically it consists of some motors, actuators, right? So those things has to be controlled by some software which can be either open loop or a closed loop. But as I was telling, that there is always a risk by going open loop system, because it is not possible that whatever you have given command actually happens there, because your conditions, your environmental conditions won't be same always. There will be always some dynamic loads which will have a effect on your motor, so displacement will differ. Backlash will be always, some backlash will be always there. So that has to be measured by some sensors. Okay, so quickly about these, right, we see these things most frequently in industries where there will be a conveyor belt, objects will be passing on the conveyor belt, and then some robotic arm will come and pick and place it or pack it or drill it or paint it. These things is most frequently used applications. Okay, so quickly about interfacing part. Where to connect these motors? When you have a motors, right, these motors, it requires around half a ampere of current. Half a ampere of current. Now if you see, I have a nice touch keyboard, right? I have developed some small software. Okay, now I will show you how to control this motor. Okay, now the motor is stopped. A small keyboard which is there here, which is controlling these motors. Okay, now I will say that, okay, forward. Now it is rotating in one direction. Now I will say reverse. Can you see it is rotating in the other direction? Okay, I will say stop. There is a keyboard problem. Okay. So what happens is, this motor may be half ampere, maybe 1 ampere, 2 ampere, 5 ampere, but I am controlling by my microcontroller, which is working on 3.3 volts. Right? The amount of current we have discussed in digital electronics hardly can source or sink around 4 milliamperes of current or 16 milliamperes of current. So how to control these motors? Right? So whenever I want to interface anything to my ports, right? The ports can be unidirectional or bidirectional. Okay. So whenever we connect these either LEDs or switches or motors, we always said there are two ways of connecting these devices. Either they can be in a sync form or they can be in a source form. In a sync form means from the VCC, right? From the VCC, the current is flowing to the inside the controller. Source means actually the controller is supplying the current. Most of the cases, sinking current is more than the sourcing current. Usually, maybe 3 times. Sinking current is 3 times than the sourcing current. So that is what is a preferably interfacing part. But if it is a LED, right? Connecting a LED is fine. You can connect it to the microcontroller because, as I said, around 16 milliamperes of current it can sink, but not the motors. So as far as these input-output I/O lines of the controllers are concerned, connecting a switch, connecting a LED is okay. Directly you can connect it, but not the DC motors, stepper motors. Okay. So the LEDs, as we have seen in the previous lectures also, directly you can connect it to the ports. There is no issue because maximum at the most you require 10 milliamperes of current. Then it is possible to a port of any controller, any digital IC can easily source that much current. There are several ways of interfacing the LEDs. If you want to increase, right, the number of LEDs, you can also connect in a matrix form, rows and columns. So you will have to select a specific row and then select the column. Accordingly, a particular LED will be on. But then, as you can see here, this is also correct, this is also correct. But the advantage of going by this is they are directly connected. Whereas here, it is in a matrix form. You will have to do scanning. Okay. In scanning, the problem is the data, whatever you are sending, is not direct. It is indirect. It is in a coded form. Unless you give the row and the column, right, a specific LED won't be selected and on. But why I am specifying this example is because if you see this combination, at a time, one row and one column you will have to select. Okay. But then, how many LEDs I can on at a time? At a time only one. Right? Whereas, in this case, all the LEDs I can make it on because every LED has an address. Every LED has a port line which is connected to the controller. But here, I do not have, for every LED, I do not have a direct address or direct port line from the microcontroller. That is the problem. Okay, but still, though I can switch on one LED, but still I can display some numbers, some text, all these things are possible. How it is possible? How it is possible? The same thing, it is applicable to the motors also, remember. Because remember one thing, whether it is a LEDs or switches or DC motors, stepper motors, any of these things, their speed is not in microseconds or nanoseconds. These all electromechanical things, human interface is there, right? They take seconds. You can switch on or switch off the motor, you cannot do it in micro or nanoseconds, right? That is the reason why I am using inside those relays. I use relays. You see, whenever I have changed the direction, I use the relay. You can listen the tick sound. Okay, or in air conditioner also you can listen the tick sound. Refrigerator you can do that. It's a relay, electromechanical. There is a spring-loaded mechanism is there inside that relay. When it is not energized, this contact point is pulling down, and when it is energized, it will be pull up. If it is de-energized, it comes back. So that means you are making or breaking the contacts by magnetic field. Okay, but then can I switch it in microseconds? Can I change the forward reverse in micro or nanoseconds? I cannot do that. Maybe in a half a second you can do that, not less than 100 milliseconds. What is the speed of the stepper motor? With what speed I can switch on this motor? Can I rotate in micro or nanoseconds? You cannot do that. It is always in milliseconds, right? So you talk about any motors, whether it's stepper motors or DC motors, servo motors, or even when it comes to human interface like switches and LEDs, these things cannot be done in micro or nano, though your microcontroller can send the data through I/O ports in micro or nanoseconds. It's not possible. Okay, because they are made up of, in case of a motors, they are made up of inductors, right? And as far as LEDs is concerned, though it is a semiconductor device, but switching very fast, the eye cannot sense. That's why we do not want that LED to switch it in micro or nano, because of the persistence of the eye. Okay, so it is perfectly okay. That's why you will find in railway stations and airports big LED displays, right? Thousands of LEDs are there, but do you think that 1000 LEDs has 1000 I/O lines? It's not possible, no. In this figure, you have 8 LEDs, 8 I/O lines from the microcontroller. So if you go by this design, thousands of LEDs require thousands of ports from the microcontroller. It's not possible, those many ports from a controller. So obviously, you must do some multiplex and demultiplexing, encoding and decoding. Okay, so if you go by this, as you have seen at least in this figure, 4 by 4, that means though you have 8 lines, but still you can interface 16 LEDs. And we do not want to display the data in microseconds of time, so that is, it's okay. We can quickly, I will switch on this, then this, then this, then this, again I will come back. You feel as if a beautiful text is displayed, but as a matter of fact, only one LED is on at a time. Okay, so that is how scanning is happening. Scanning. These are all scanned displays, scanned controllers. Whereas controller like in EPBX machine, you have so many people are connected to 1 or 2 leased lines. How 1 or 2 leased lines are sharing hundreds of people, right? So multiplexing, you are switching so fast that you are not aware that for a fraction of a second actually you are interrupted. Your voice is not continuously transmitted, right? A part of it is sampled. In between some data is lost, but then you are not aware of it. It is happening so fast that it's okay. It's a sampled data. It's not a continuous waveform. It's a discrete time wave. So same thing here. I mean, we are not displaying at a time. At a time, we are scanning. Okay. So even you can make it even more complex using multiplex and decoders, right? Mux and demux. So that, for example, as you can see, the 2:4 and then 4 by 4. That means you hardly require 4 lines, but still you are interfacing 16 LEDs. So that is how you can always think of how to increase the number of interface lines, I/O lines, so that, right, you can connect more and more motors, keyboards, LEDs, switches. Right? So similarly, it is applicable to 7-segment displays. There is no difference between a LED and 7-segment displays. Both are same. Only thing is they are integrated in a small IC form. So that whereas here you have LEDs, 7 LEDs are placed to display the numerical values. Fine. When it comes to switches, right, there is no difference. Only thing is the data direction is input. Instead of output, we are saying input. But only one problem is there as compared to LEDs. In case of a switch, as you can see, whenever you press a switch, right, the switch is not constant high or constant low. There will be some transient output will be there, not steady state. This is called bouncing. High low, high low, high low for some time. Always this, because these are all spring loaded switches, right? If you press, you think that you have pressed. Actually it's not pressed. Or if you release, you think that you are released. But it is not completely high state or completely low state. There will be high low transitions will be there, right? As you can see. This is called bouncing. So these are the things you will have to take care, because as you have seen this product, it's not only controlling the motor. I have to use some keyboard and display and set my parameters, that how do I want to make some displacement. Like in this case of a robotic arm, I have some sort of a keyboard where I will have to set what I want to do it on that. Right? So when you are interfaced the keyboard, you have problems. It's not that if you press a key, then it will recognize as a key press. No, if you press one key, it recognizes as if you have pressed the key 10 times. If you release the key, it feels as if you have released the key 10 times. So then controller should not feel that 10 as a count. Controller should get 1 as a count. Okay, I will show you some demonstration where I have to enter the data. I will have to say that, okay, after so and so time, make the displacement by some so and so number. So how to enter the number? By using, see, only 4 switches are there. Only 4 switches are there, but how will you enter the numerical values? By using 4 switches. Okay, so you don't get those luxurious things like in computer, where ASCII keyboard and beautiful monitor is there, right? Not that. Here just a simple textile CDs and 4 mechanical switches are there, that's all. The complete data you will have to enter by using these 4 switches. This is how the industrial products works. Without using any computer, how you make them as a standalone systems. Okay, so key bouncing is a problem. How to avoid the key bouncing problem? There are solutions are there. One is called by using some latches or integrators. You have to filter out that noise. But this is, as you can see, the problem of using this solution is a lot of circuit is required, right? You require 2 gates and all that. Additional hardware is required just to interface the switch. Instead of using this bouncing circuit, the second solution is delayed cooling method, right? Whenever a key bounce is detected, right? If you get a key bouncing, then during this period, don't read the data. Whenever controller recognizes there is a low to high state or high to slow state, don't read that data. Avoid it during that period. And let us say, for example, 10 milliseconds, if this problem is there, then after 10 milliseconds you read the data. Right? You have recognized there is a key press. You have recognized. Then what you do? Call a delay, 10 milliseconds. And then after 10 milliseconds, come back. Again confirm. Is the key is really pressed? Yes. Then it is a confirm. If it is not pressed, then it must be a bouncing. Avoid that. Right? So you must have some solutions to overcome these problems. But again, the problem is same. If you are using individual I/O line for a switch, then for 8 switches required 8 I/O ports. But if I use a matrix form, like I want many switches to be interfaced, then you can go by this rows and columns approach, where you are reading the data but in a scanned form. Okay, slowly you can develop these programs. Fine. So finally, about these sensors, optocouplers. I was telling about how to measure the displacement of the motor. Okay, whenever some dish is rotating, I want to know by how many degrees it has rotated or how many revolutions it has made. How to sense that? If you are curious, you can open the mouse also and you can see where there will be always a optocoupler, right? In such kind of closed loop motors. One side you can see there is a photo transistor, other side there is a photo LED is there. In between, right? In between what? That motor dish is cutting the light. So whenever there is one revolution is completed, or whenever if you have so many holes, then whenever it completes one hole, the light will cut this thing. Then a pulse is generated. So we have seen some programming examples of how to generate interrupts on the controllers. Right? So whenever there is an interrupt, we have done one program, right? If you remember, on LCD we are displaying the count. Right? So whenever a pulse comes, then we have to count it. So that is how, where you have to count this, how many times the light has been cut. I will give you some sensors, maybe in the afternoon you can practice it, right? So that is how you will have to measure the displacement factor. So there will be, usually optocouplers are used for measuring the speed of these motors, because absolutely there is no contact is required. They are contactless. Even if I want to measure the speed of this fan, from here itself I can measure it without having any contact, because the light is being reflected here. You can see, you emit the light and the light is reflected, and whenever it cuts the light, then there won't be any reflection. Okay, you can see the shape, how the shape looks like, different types of optocoupler. It is in U shape, and then one side there is a light, other side there will be a sensor. Then your motor's dish is kept somewhere here. That is how it works. Hall effect sensors. This is another type of sensors where you can use in motors. It works on some magnetic principle, right? As you can see, when it depends on the type of assembly. So it's a 3-pin. It's a basically a transistor type of mounting. It's a 3-pin this thing. One is your VCC. You apply some voltage and connect the ground. Third is the output. And then depending whenever there is a magnetic field, right? That means current will be flowing through this, right? Then there will be some transistor type of assemblies there. It just looks like transistor, right? 3 lead, as you can see, the popular numbers are some U28 or some numbers are there. Some companies are manufacturing. So what is that you require is the motor should be mounted with some magnet, maybe some permanent magnet. Then you should have this 3 lead transistor. Whenever that magnet comes near the transistor, right, a current is produced in the sensor because of the coupling. That is converted to a pulse. That means the motor should be mounted with a small magnet, permanent magnet. Okay, so that is how you are measuring whether it has completed one revolution or not. Okay, so these are also popularly used, and there are also types. Distance measurement, right? Sometimes I will show you in the afternoon, we need to measure the distance also. When I am talking about, for example, that solar dish, daily tracking happens from east-west, but seasonal tracking happens north-south. Okay, north-south, this tracking is 46 degrees, this dish. So if this 2 tons of dish, right, actually either you will have to compress it or you will have to expand it by 46 degrees. This is called seasonal tracking. That means the sun displacement in a year, right, north-south is 46 degrees this way. Okay, that means the dish either has to be bended, right, or you will have to expand it. But imagine in 365 days, the displacement of north-south is 46 degrees. So imagine per day what will be the displacement factor. Maybe less than a degree, right? So imagine what should be the accuracy of those mounted motors. They have to bend the dish by so and so degrees. Okay, whatever. So there are some sensors, what is called popularly known from the Sharp company. Sharp company manufactures these sensors, infrared sensors. This infrared sensor will give the displacement, right? You can measure the displacement. Distance you can measure. If you are interested in measuring the distance, how much distance a specific motor has traveled, that you want to measure the distance. But I had given one challenge to all of you, that linearization of the non-linear systems. For example, if you see the sensor, right? If you see the output voltage and if you see the distance in centimeters, linear system means what? Linear system means if, for example, if the distance is 1 centimeter, voltage is 1 millivolt, 2 centimeter 2 millivolt, 3 centimeter 3 millivolt, always a straight line. But non-linear means what? Say for example, initially as the distance increasing, this voltage is rising. But after that, the distance is increasing, but you can see the voltage is falling. Okay, it is not linear, right? You cannot develop a simple mathematics saying that if 1 centimeter means 1 millivolt, you cannot develop that kind of equation. So this is a non-linear sensor. So in case of a non-linear systems, how will you linearize them? Is that problem statement is. You want to measure the distance, right? But then it is not linear. Up to 80 centimeters it will measure, but then it is not a straight line, right? It has some non-linearities in the shape. So then how to measure the distance is the problem statement. A lot of mathematics are there. Okay, so it's not that always we have some these DC motors. We also sometimes use the solenoid valves. So for example, in process control instrumentation, it's not the motors, they are the valves, right? Say a robot not necessarily always controlled by DC motors or stepper motors. They are also controlled by pneumatic control systems and the hydraulic control systems. For example, if you see these four-wheelers manufacturing facility, if the tons, right, there are tons of weight if they are lifting, they are all hydraulically controlled machines or pneumatic controlled machines. They are not, motor is not lifting that weight. Some hydraulic control system, right, there will be some oil will be compressed, then it will expand, right? Hydraulic control systems or pneumatic control systems. So how to open or close the valves, right? So solenoid valve means, looks like a simple inductor, it looks like a relay only. But here what is happening, only these contact points it is moving, either up or down. But there what happens, in case of a valve, actually whenever you energize the actuator, like say for example you have seen in railways, whenever you want to make the track position, nowadays nobody go there and to change the track, no. From the cabin itself they press one button, then the tracks will be changed, right? So that means imagine the tons of weight of the tracks are moving from one point to other point. That is the solenoid valve. So solenoid valve is basically it's operating on some high voltages and high currents, but then still due to that magnetic field, right, that movement is happening, that something is getting attracted. It's a valve. So same thing is used in pneumatic and hydraulic control systems. Through those pipes, right, whenever you want to pass some fluids, right, then what you do, there is a solenoid valve, either it's open or closed. That means the high pressure fluid is passing through that valves. So basically you need to control a inductor. Inductor current you will have to control. Only shape is differing from one application to the other application. Okay, fine. So it is a coil. All these actuator is nothing but it's a coils. In case of a servo motor, the story is slightly different. In case of a DC motor, in case of a stepper motor, you are only controlling the current flowing through that coil. Or in relays also story is same. In solenoid valves also the story is same. It is a coil where current is controlled. The current is controlled by either by using some transistors or MOSFETs or by using these relays. But whereas in case of a servo motor, Servo motor is actually a closed loop control system. Servo motor directly you can connect it to the microcontrollers. Directly microcontroller I/O lines can control this servo motor. Right? In case of a servo motor, as you can see, this is a closed loop control system. Right? You have a DC motor, right? But then what is happening? The position of the DC motor is being continuously sensed. You generate some signal and internally it will measure whether the displacement has happened or not. That means whenever you make some displacement, some motor, you can say for example potentiometer. Potentiometer is rotating inside this motor. Right? So this displacement of this potentiometer and the signal which you have given, both of them will be compared by some amplifier, some comparator. So the comparator will generate a error signal. This error signal again will give some action, right? Some pulse to the motor, so that again it will make the displacement. Till the error becomes zero, right? This will be keep on happening. Okay, it's a closed loop system. Most of the sophisticated robots use servo motors. For example, your 3D printers, right? 3D printers or these laser printers, inkjet printers. All the printers use these servo motors. Precisely you can control, right? DC motor precision is not that high. Stepper motors see, problem is finally what is your application. If you want to control the position of a pen on the plotter, how accurately you want to control it, accordingly you have to think of what kind of mechanism you want. So plotters, printers, right, or sophisticated robots uses servo mechanism, not standard DC motors. Because controlling by some displacement in mm displacements if you want to achieve, then servo motors are best. Okay, in short, the servo motor principle is the displacement of a servo motor is controlled by pulse width modulation, PW. PWM signal you will have to give. Okay, but as I said, but then how will you make sure? Because your dynamic loads are keep on changing. So obviously, whatever the signal you give, then inside there is a feedback control system is there in the servo motor. Servo motors is always 3 wire, remember. DC motor is only 2 wire, but servo motors is always 3 wires. One is VCC, second is ground, third is the signal. And that signal is not high state or low state, remember. The signal is PWM signal, pulse width modulation. That means whatever is the displacement factor you want to achieve, for that what is the width of the pulse you will have to give. For example, I want 1 mm displacement. Then PWM on time will be so and so, off time will be so and so. It's always width. Width of the pulse will give the corresponding displacement. Okay, and then till that displacement error becomes zero, there it will be keep on taking the feedback from the output. So it's a closed loop system. The servo motor itself is a closed loop system. As you can see, for example, a simple example is given here. If you want to have a 0 degrees, then what is the width is, let us say 1.25 milliseconds pulse you have to generate. If you want to have a 90 degrees displacement, give a pulse of 1.5 milliseconds pulse. If you want to have a displacement of 180 degrees, generate a pulse of 1.75 milliseconds. Okay, so that's the advantage, that your pulse width is defining the displacement of the motor. Today, even the hard disks are replaced by servo motors. They are not using no more stepper motors, because in stepper motors you still have some, you cannot achieve less than so and so degrees. And since day by day the density of your tracks are keep on increasing, so they are using servo motors even in the hard disk. Is it clear now what are the types of motors? Motors are basically all made up of inductors, coils. and the coil current, amount of current which is passing through that, it depends. For example, as you have seen, this is a 5 ampere motor, right? Whereas the motors which we use in, like in your camera, you are opening the lens and closing the lens, all of them are operated as such a small tiny batteries. Okay, but then we also said about the four-wheelers, right? Tons of weight if they are lifting, they are not actually a motor, but they are solenoid valves, right? Amperes of current is flowing through them. In railways, you have seen when they are lifting the tracks from one place to other place, amperes of current is flowing through them. All of them are basically coils, right? Coil is nothing but, as you have seen in case of a relay, there is a coil, right? Just a two wire. When the current is passing through that coil, electromagnetic field is generated. That field, right, magnetic field, will attract some point, will push that, right? So that is the same thing is happening everywhere. But the problem is that current is how much? Milliamperes or amperes, accordingly the design will differ. If it is a huge current, then we use the relays. To drive them, we use the relays, right? If it is few milliamperes of current, then as I have shown you, I/O ports of the microcontroller also can switch on or switch off them. Is it clear? So, programming these controllers, right, programming these motors, this topic